All right, let's dive right in. We're talking about NVIDIA's Nemotron-3, and you might be asking, why should I care? Well, here's the thing. This isn't just another large language model. We're looking at a complete rethink of AI architecture. It's built for a future of smart, autonomous agents that can actually do stuff for us. A whole new playbook is being written here, right now.
But, to really get where we're going, we first have to understand the massive wall we've just hit. For all their amazing power, today's large language models, they're at a critical turning point. They're staring down some pretty serious architectural limits.
So what's the real problem here? It's kind of like these giant one-size-fits-all models have become victims of their own success. Their core attention mechanism that makes them so smart, it's also super expensive. It's just crushing memory bandwidth and sending computing costs right through the roof. And let's be honest, businesses today aren't just looking for a slightly better chatbot. They need teams of specialized, efficient AI agents that can actually get work done.
So here's how we're going to break it all down. First, we'll tackle that efficiency bottleneck. Then, you'll meet the new Nemotron-3 family. After that, we'll pop the hood and look at its hybrid engine. We'll also explore this really clever thinking in blocks method, see how you can control the thinking budget, and finally, talk about what this means for building an open future for AI.
Okay, let's start with the big problem, what people in the field call the quadratic wall. Just think about it this way. If you double the length of a document you feed a normal AI, the cost to process it doesn't just double, it quadruples. It explodes. This is the fundamental challenge Nemotron-3 was built to absolutely smash through.
And this quote just hits the nail on the head. It really gets to what the market is screaming for right now. The endgame isn't a single, all-knowing AI anymore. It's about building these complex systems where lots of different AI agents work together to automate entire workflows. And that requires a whole different level of efficiency and specialization.
And here is NVIDIA's answer. The Nemotron-3 family isn't just one giant model. It's a whole portfolio, a whole family of models, and each one is purpose-built to break through that efficiency bottleneck, just at different scales.
Okay, now this is where it gets really fascinating. Look at the difference between total and active parameters. Think of parameters as like the neurons in the AI's brain. So the Nano model technically has 30 billion total neurons, but, and this is the key, for any specific task, it only needs to wake up about 3.2 billion of them. That's the magic of this mixture of experts thing we're going to unpack in a second. From the nimble Nano all the way up to the beastly Ultra, each one has its job.
And the result of this new architecture? It's just stunning. The Nemotron-3 Nano model can deliver up to 4 times the token throughput of older models. That's not a small improvement. It's a massive leap. It's going to dramatically lower the costs and the lag of running these systems at scale.
So the big question is, how did they pull this off? Let's get under the hood. The key to Nemotron-3's power isn't some single silver bullet. It's a really brilliant combination of 3 different architectural ideas working together.
It all rests on these 3 pillars. First, you've got Mamba 2 layers. They're amazing at handling really long streams of information without that crazy quadratic cost explosion. Second, it still has the classic transformer layers for that high-precision, deep reasoning they're so famous for. And third, the whole thing is coordinated by a mixture of experts router, which smartly activates only the parts of the model you actually need for the task at hand.
This really shows you the genius of the design. On one side, you have Mamba 2 giving you raw speed and efficiency, especially with huge documents. On the other side, you have the transformer layers for that pinpoint accuracy you need for, say, complex logic problems. With Nemotron-3, you don't have to choose. You get the best of both worlds.
And this mixture of experts, or MoE, it's basically the conductor of the whole orchestra. Picture a huge library, right, filled with experts on every topic imaginable. Instead of making every expert read every single word you send, a smart router directs each word, or token, only to the most relevant expert. This is exactly how a 30 billion parameter model can run with the speed of a 3 billion parameter one. It's all about selective intelligence.
But the innovation doesn't stop with just the architecture. Nemotron-3 also changes how the model thinks. We're moving away from predicting just one word at a time to predicting entire blocks of thought.
See, traditionally, language models work word by word by word. It's very sequential. But multi-token prediction is totally different. It predicts a whole chunk of text all at once, like a complete line of code or a full mathematical expression. This lets it understand the structure of an idea, not just the words in a line. This quote from the research paper just nails it. When they say unified semantic actions, what they mean is the model isn't just trying to guess the next word in a sentence, it's trying to complete an entire coherent thought. And that's a way more powerful and efficient way to reason.
Now, this is where things get incredibly practical, especially if you're a developer. All this power is great, but you have to be able to control it, right? Nemotron-3 introduces a super simple but powerful way to manage that classic trade-off between speed and depth.
It's the dilemma every developer faces. Do I want a fast, direct answer right now, or do I need a more deeply reasoned, super accurate one that might take a bit longer? Well, with what they call the thinking budget, you don't have to make that choice permanently. You can just dial it in for each specific task.
And the controls are beautifully simple. You use /think in your prompt, and boom, the model literally shows its work. You get a full, detailed reasoning path. Or if you just want a quick answer, you use /nothink for a direct, fast response. And here's the best part for anyone worried about budgets. You can set a hard cap, a max thinking tokens limit. This means you get predictable costs and response times every single time. No surprises.
Okay, finally, let's zoom all the way out, because Nemotron-3 is way more than just a set of models. It's really the foundation of NVIDIA's much bigger strategy to build an open, accessible ecosystem for creating the next wave of AI.
And they're not just dropping the model and walking away. They are backing it with huge resources. To help anyone turn these models into highly specialized agents, NVIDIA is providing 3 trillion tokens of open data. That is a massive kickstart for the entire community.
This is the whole toolkit. They're giving away the model weights under an open license, they're providing those massive datasets to train on, and with tools like Nemo Gym, they're giving developers these digital playgrounds where their AI agents can actually practice and get really, really good at complex tasks.
And let's be clear, this isn't just about being generous. The strategy here is to make the NVIDIA platform the absolute best, most efficient, and most powerful way to build these AI agents, from their open models all the way down to their hardware. It's a full-stack play to become the default engine for Agentic AI.
So that really brings us to the big question, doesn't it? What NVIDIA is doing here, they're essentially handing developers the keys to a brand new kind of factory, one that builds specialized, intelligent workers. The foundation is open, the engine is efficient, and the budget is controllable. So the only real question left is, now that you can build an entire workforce of AI agents, what problem will you solve first?